Hope you are all well. Yeah, I'm going to give you an insight into something a little different. Most of you probably already know or have heard of BARN, but we've been going since 2011, and we've been building full-fibre networks back then in 2011 to some of the sort of deepest rural parts of the north of England. And I'm going to talk through some of the challenges that we faced at that time, some of the challenges we still face today, how we operate the network, because what we've done is we've built it from the ground up, and we are our own internet service provider as well. So, who are we? We are actually a community benefit society, and what that means is all of the communities that we connect, they are also the shareholders. They put the funds in to help build the network in their own communities. Coupled with that, since around 2017, 2018, and the introduction of the voucher scheme from the government, we were able to utilise that and bring in some government funding to come and help build this full-fibre network. And as I said before, we use full fibre all the way, so we've actually put over 5 million metres of fibre in the ground, and that figure was reverse engineered from our accounting system to find out how much fibre we'd ordered and put into the ground. So it's quite a lot, and all of that is blown fibre. So what we do is put everything under the ground, and we don't use any pole infrastructure. One of the big reasons for that is because in the deep rural space, quite difficult terrain, yes, to put duct under the ground, but once it's in, you never really have to touch it. If you've got pole infrastructure going long stretches, weather tends to take it down quite often. Yeah. So having duct in the ground and using blown fibre is a brilliant solution. And yeah, we have over 12,000 live customers now on this network in the north of England, and they have all got a gigabit symmetrical connection through a fibre in the ground all the way back to the central nodes, and they pay £33 a month for that. And it's all you can eat. Just keep going, use whatever you like. And one of the reasons we could do that is because we are set up as a community benefit society and it's their money behind it, we can make the best engineering choices to provide the best service to those customers. So instead of having private equity coming in and then having a controlling stake in how you're operating your business and making a return for those investors, etc., actually our investors value the service that they receive over making money, right? So that's where we can plough the money back into the very network that we're building. So technology choices. We like to think we're making the best technology choices. So what we've got here is point-to-point fibre, right? We don't use PON, GPON, XGS-PON, etc. They're all exciting technologies, right? But if you go in the deep rural space, one customer could be 500 metres away from your cabinet. The next customer on the very next fibre could be 10 kilometres away from the cabinet, right? So that it's a huge wide area to cover from central cabinet nodes. So it doesn't really make sense to split your fibres up and use them in that way. So we've gone for point-to-point. And one of the great things is we can use bidirectional optics, and they're very, very cheap to get a gig symmetrical. Also very cheap now to get 10 gig symmetrical. So we do offer a 10 gig residential service. Nobody really needs it, but it's there. And where it is needed are some of the higher education sites or university sites or anywhere like that where we can actually put a 10 gigabit dedicated service into these places who are in small market towns or are in these deep rural places. It's great to be able to give them a high level of bandwidth that is highly available, talk more about that in a minute, at a very good price point because, again, as part of that community, all of the kids go to these schools, right? And so if we can provide a high level of service for a very reasonable cost, then that's more money that these schools can use to spend on their education needs, etc. And a point which I skipped past before, we do actually have over 220 free services that we provide. These are churches, small primary schools, and community assets, where actually they've made a case to us saying, look, having a broadband service where we're paying a few £1,000s a year is a real thing for us. And we say, well, what if we can do it for nothing? You can then spend that money elsewhere. So we've done that. Again, supported by the community. So going back to the technology, yeah, it's great. I love it. I absolutely love working for B4RN because we can make all of these choices and put the best gear in, and you know, because we look after the entire operation and we have very, very few third-party circuits involved, we've got full control of how we actually operate the fibre and the links on the top of it, how we maintain it, how we look after it, and how we upgrade the equipment on it. Planning the network is very interesting. I've included this one. I've got quite a few slides, so I'll rattle through them. But planning the network is important when you're in deep rural, because if you try and go down the road and dig it, it's just not cost effective at all. It just doesn't work. So what else are you going to do? Well, we don't want to use poles. Yes, it's cheap. We don't want to do that because we'll have to make, you know, high cost and maintenance. So instead, we use 90% agricultural land. Okay, and again, going back to the community point, the landowners are also included in that community, very much so. And so if we can go and talk to them, and rather than saying, sign away, leave, and then we can come on, we say, well, how can we get the network to your house? And if we can get it to your house, how can we get it to your neighbour's house? And they start to think of a solution of how to get from one place to another. They know the lay of the land. If there's land drains, problems, issues, tree roots, all the rest of it, they know exactly where everything is. So if you can then use that resource to go and plan the network, you don't need these automation tools. You don't need to drive a vehicle with a camera on the top down the road and then have it tell you how to design your network. Do it from the ground up, not the top down. So that's what we're doing on our planning. And you can very quickly get you know, a huge, vast area covered with you know, fibre that makes sense. Again, going back to the engineering, you can go the shortest path, you know, and you can have the correct fibre counts for all of these routes to collect all these people. And another good point is, in any area that we're defining, we will always put a fibre in for every single property, right? Because we don't want to be going back and adding in more capacity later on. We do it from day one. So even if only half the community wants service today, we'll actually put the fibre in for 100%. So if they want it in 3 years' time, it's just the last mile. We just put the end tail onto the connection and then they can have it. So this is what it looks like. We used vibratory mole plough gear. So if you haven't seen this before, it's basically a tracked machine. Wheeled ones aren't so good because they slip, but a tracked machine, and it has a blade on the back, and that cuts the sod, which is the top of the grass, all the way down to about 450 to 600 mil deep. And then it basically shakes the ground, and then your duct follows behind you, and then you're left with a very clean cut most of the time. And then you can just reinstate very, very quickly. And the landowners love this because they want to work the land. So if they've got crop, they're growing something, and they've taken the crop off, it is not long until they want to reseed and reuse that land. So we have to be in and out. So that's why we use these technologies. And you see the folks on the left-hand side there, most of those folks are volunteers. And what they're doing is they're coming together to help coordinate, help bring people together. Communication in any company, as you all know, is a massive, massive deal, always a problem. And the fact that we've got a vast amount of volunteers involved, they can help with the communication very, very quickly. It's better than emails, better than phone calls, better than anything else, is to have your local community talking to each other directly. Okay? And then the customer side. So this again goes back to the point-to-point argument as well. We use 2 fibres for every property. Yes, we could put 1 fibre in, but actually, generally, the fibre that you buy, 2 fibres is what you get in a small blown fibre cable, micro cable. And then all the chambers we tend to try and put you know, with reasonable access. So then we can go and blow the fibre end to end, no connectors. So we like to splice the whole way. Again, operating in a rural environment is a very dirty place. Yes, of course, we're splicing. That's a clean room technology out in the open. Fair enough. But we'd like to remove all connectors because our engineers can go in, create an environment, do the splice, get out of there, and then you never need to go back to it. Connectors and dust are a pain. So yeah, on to operating the network. So I said before, we are our own autonomous system, our own ISP. We've done this from day one since 2011. And it was done on purpose this way because we can be in full control with the service that we're providing to our communities. And it's quite nice. The feedback we do get from the communities as well is they do feel part of almost the industry, if you like, because we talk with other operators, content providers, we explain what this means, how the internet actually works. They really enjoy that. When you go to somebody and you say, how does the internet work? Not many of them can tell you how it works, right? So they'll just, I just want to get to Netflix, or I just want to get to whatever content. If you talk to them and say, well, how does that actually work? They don't generally know. So it's quite nice to be able to sort of bring that closer in. We can explain a lot of this. And on the left-hand side, right-hand side, which is the yellow cables, that's a customer cabinet. So this is where the volunteers will tend to go in there and do some patching, etc. as well. And so they're starting to understand how that part of the model works. And I just like being able to have symmetrical traffic paths wherever possible, and I know where the traffic is going as well. Instead of sending it into the ether and then you have an MPLS circuit that's popping it out somewhere else, and you don't understand what the operator's infrastructure looks like. You don't know where that's going. So if you get some sort of fault, let's say on the West Coast main line, and a fibre is cut, right? We know exactly where all our fibre is, the traffic paths they take. So if there are any problems, we know where to look. And I think that's very important when operating networks, is that you're sending the traffic exactly where you want it to go. You know it's going that way. And if there are problems or issues, very quickly solved. Okay. Monitoring telemetry is talked earlier about power systems and being able to monitor what your usage is. We monitor everything possible, because there are two ways of doing things. You can either be reactive or proactive in the way that you're looking after and monitoring your network. We like to be proactive. And sometimes I grumble a bit because our alerting system is a little bit too loud. But actually, it gives us real insight into what's going on. And so it's really beneficial, I think, to have a proactive approach. So we use various different open source tools. So we can see what the CPUs are doing, see what the power systems are doing, see what the switches are doing. The team are working really hard on automation at the moment, because in the early days of BARN, it was all on the keys. We just got on with the job, we just got everything done. Nowadays, with 12,000 plus customers and over 300 devices to look after, and several data center core nodes, etc., it can't really be done on the keys anymore. It's got to have automation. You've got to be able to fault find on the configuration that you're going to be putting in. Comments earlier about finding the faults before the configuration goes on the network. I think that's absolutely fantastic, because you don't want to take your network down like ever. And so if you're getting to the point where your scripting is telling you, actually, hang on, what's this, and this going on, you can solve that before you then push it out to your devices, and then customers don't see a problem. So yeah, very, very much support utilising as much open source software we can get our hands on. Also, then trying to whatever we're coding within these systems, give back to that community as well. Can I do questions at the end, or do you want to do it now?
I just wondered if you could go a bit more into it. You cannot reiterate how important it is to have an in-house development.
Oh yeah, absolutely. In-house development team, right? It means, again, instead of engaging with a third party and saying, I have requirement X, okay, so this is what I need, and then you go and then ask them to develop it. They come back with Y, and no, I need this, and then they come back with something different, and eventually you get something that's halfway there and you get it implemented and it doesn't work. I've experienced that so many times, where it's hard to get the message across of what you really want. You could have the best documentation, project plan that you could put together, but actually, if you hire the folks and you have an in-house team, that's much easier to communicate, and you end up with a better product, in my view. Does that make sense? Yeah. That's the way we like to do it. I wanted to talk about this one, the copper switch off, because actually it's been going on for quite a while, but the public is starting to rise to this and starting asking all the questions. So yeah, since 2021, Openreach have been ceasing the sale of copper products, right? Because when an exchange area has 75% plus of fibre availability, you're not going to be able to order copper anymore. They'll keep it going, right? So if you've not cancelled your service, they'll just leave you alone. But if you want to change that or a new service, no, sorry, can't have copper anymore. It's been happening for quite a while, but this date has come up. The media has spun this massive switch that's going to be, clunk in 2025, and the whole thing's going to get turned off. and that's what people think. And so, even out of our customers, because historically we've only done broadband. Thankfully, Monday this week we've launched our VoIP product. And it means now that we can help people come onto our phone system. But it's a case of the media have got all the spin of what's actually going to happen. Kind of isn't that. But at the same time, I know that Openreach have got a big effort now, little pop-up vans on what this means, how it's going to work, convert from one to another, all that sort of thing, just to be aware of. And the stat on the bottom there is from Think Broadband. I think it was the August figure I pulled there when I did the slides. Just the availability of gigabit connectivity is going up and up and up at the moment, which is great to see. Lots more fibre being put out there. 100 plus altnets building fibre at the moment. Booming right now. But what's the impact of all of this? One of the big things we're seeing is what isn't going to work. So healthcare alarm systems, burger alarm systems, the management of all your machinery, factory machinery, or the example I've given here is where we've got hydro plants that have been put into place and they have machinery inside, etc. And a lot of them have been designed, these fundamental control systems have been designed to use copper. So what do? Do you either have those systems developed so they can take an Ethernet connection or a fibre connection or whatever, or do you have something that can do all of that job and then convert it to go and talk to whatever's there existing? One of the biggest issues for us, just because of the area that we're operating in, we have a lot of people who need these care alarm systems to work properly. It's a problem. It isn't solved yet because you can't have a device that is a digital care device that's going to send an alarm, convert it to analog to go to the box in your house that's going to try and convert it to digital to then go out. It just isn't going to work. So this is still a problem. I think vendors and people who are looking at all of this are kind of playing catch-up for the moment. I'm happy to be told wrong if there's anything happening out here in this space that I don't know about. Please tell me, because it is a problem for us. But that's one of the big impacts. It's just great that we've had a couple of hydro plants on our network for quite some time now, and they've figured out how to do it. So, our fibre router goes in, comes out as Ethernet locally, they can set themselves up and they can start to manage and monitor what's going on in those plants. So there you go, that's kind of a general overview of Barn and what we're doing at the moment. There are lots of other altnets out there doing it, but the main difference for us is we're doing it for the customers, the communities that are there. So we have a very different angle on all of that. Now on to what we're calling the Halo project. So currently we are operating basically that network you're seeing, but on multiple 10 gigs, bonded 10 gigs, right? So we put, I think, 2015, 2016, I think, was when some of the first of our DWDM long lines went in with 40 channel muxes, multiple 10 gig channels on that network, and then bond them together as you go along, and you can add capacity. That's not enough anymore. It's run for long enough that we now need to refresh all of the gear. And it's quite an exciting thing. I know a lot of other operators are choosing to go to 400 gig. This is what this is going to do for us as well. So we can talk about that. But yeah, just one big thing about having a network that you're creating a ring, even for the size of us. We're not one of the biggest operators, but actually what we pride ourselves in doing is providing the best service to our customers. So having a network that is a complete ring in the north means that we can actually take down each individual leg whenever we like. Okay, and we can service it, we can maintain it, we can repair equipment, etc. We do currently have multiple paths to get around things, but it's not good enough, in my view. And operating a network in this way means that service is always going to be on for those customers. So here we go. I've included you two in these slides. I've got David and Jimmy down there. they'll not thank me for this one. But we've actually spent about 12 months planning this because it's a huge thing. And whenever you're planning a big project, and you'll have all been through this in everywhere that you've been, it's just managing that process and making sure that when it comes to deployment, it just gets deployed. Okay, so we've had a lot of planning sessions on making sure the circuit diagrams are correct, the light levels are going to be correct, what type of fibre you're running in the network, how long does it run for, etc., etc. That's the stuff that really excites me, because it's where the magic happens, right? And if you do all of that right, you plug it in and it just works. But one big thing is auditing absolutely everything. We've found that actually, if you do have, maybe you're physically putting labels on things, etc., that's okay, but you need to do everything. Physically label it, logically labeled it, port descriptions on everything, even layer 2 circuits or whatever you're doing. Just label absolutely everything, and then put it all in diagrams, right? So then you can update and figure out where you are. Again, problems, you know where you're looking. What gear are we going to use? We're going to use the Juniper Fleet. We've used this since day one. In 2011, we actually launched with an MX240 straight away. I think we only had, I think it was a 10 gig transit port with a 1 gig bearer when we first started, but so be it. And that served us really well. So now we're going to retire that fleet of equipment, go for the MX304. And some of this stuff now is really getting exciting. The way that these platforms are actually built and the amount of automation and monitoring and live telemetry that you can get from these devices is just amazing. So the guys down there are going to really look at how we can leverage that from these platforms. And again, being able to see exactly what's going on within your network, I think, is really important. And these devices will be able to do that for us. And it just so happens that now is the point where it's coming for the technology refresh. We've ran the network for 7-8 years now on the core. It's time for it to get refreshed. So we're going to be using this gear. It's quite exciting stuff. But I'm probably preaching to the converted when I'm talking about how to put all of this in and the operation of all of that. Some of the really exciting stuff for me is how do you even get 400 gig? So we spent a lot of time working with smart optics, right? So we've used smart optics before in our network, and this was when it was the early days, and we were just, let's have four times 10 gig, please, right in the early days. And now what we're looking at is a 400 gig channel all the way around the north of England, and then have all of the other channels available for other services or whatever else we might want to do. So when we put the gear in to begin with, and some of you will have experience of this, it was all modular, right? So you had your chassis, and then you had your booster, your preamp, your OEO, or whatever else is that you might need in there, or your dispersion compensation units, etc. You had to figure out exactly what you needed, and then you put the exact right things in for that leg of the network, right? So this is down to the attenuators. So then your optics were actually balanced at the exact right level, going into all of the equipment. And, we put a lot of this equipment in. We had many regeneration nodes on our network, and it took a long time to put in. And the engineers learned a great deal about DWDM, how that worked. Nowadays, see that one new chassis, right? It's all done in one piece of kit. Absolutely amazing piece of kit. I still haven't got my head around the fact that it can do it all for you. So this piece of kit, which is the DCP-M40, right, is where you can plug in your line, you can plug in your various different optics, and it will figure out for your access optics what level it's receiving at, okay, and then balance it internally. So then when it's going out on the line, it can figure out exactly what power levels the optics need to be to go on the line. And the line itself is actually talking either end to each other, and it's figuring out what it needs to set itself as. All of this was manual when we were putting it in first time round. But these pieces of kit are just something else. And so, yeah, for me, I just hope that in the modern age of the modern hardware, the engineers are still getting to understand all the mechanics of how these pieces of equipment are working. Because if you start to put them all in and it's plug and play, there could be a tendency that the engineers will say, well, the planners have told me it'll work. I've stuck it in and it's worked, so I'll just walk away. For me, I'm really positive on upskilling. Whether, for these pieces of kit, we aren't going to need to manually attenuate everything and actually work out the losses manually on your computer as you're going. You just plug it in. But I just think, as an industry, we could really do with lots and lots of people understanding the mechanics of all this equipment and how it all works. So, yeah, this is it. The 400 gig again, just as the technology on its own, never mind the piece of kit you're using. We're using coherent OpenZR 400 gig optics. And, this space was new to me. The fact that actually what you're doing here within your transmit window is that you actually have quadrants. Thank you. My English is bad. Right? And each one of those you can actually transmit and receive. Okay, so it's very hard to visualize. It took me a while. But you can see from the circle there, you've got 16 quadrants, right? And within all of those, you can set the signal, and sometimes it's spaced this way, it's spaced that way, and the technology is just absolutely mind-blowing that you can fit all of that data down one channel and to get 400 gig. And by the way, you can have 40 channels on the same pair of fibers. Just unreal. And so that's what we're using. And one big learning thing for me as well is the channel bandwidth for 400 gig is actually much wider, naturally, physics. And the current MUX-demuxes on the network, yes, they are 40-channel breakout points, but they're only 50 gigahertz spacing. Doesn't fit 400 gig. Try and put it in, chops the edges off, doesn't work. So you have to replace all of the MUX-demuxes, etc. But again, all built in to that one U chassis. It's just amazing. So that's what we're doing. And in a few months' time, into the new year, we're going to end up with this 400 gig ring across the north of England. If anybody would like access to it, please let me know. But what it's primarily there for is to serve all of our rural customers with everything they need. Our traffic levels have just skyrocketed, right? Since people started using the internet a lot more for things, gaming, streaming, you name it, it's all there. And actually, we're plotting, if we didn't connect any more customers, and you see the usage over time based on the past projected forward, our network wasn't big enough. Even multiple 10 gigs, just one wasn't big enough for 12,000 customers. So we had to make this leap. And yes, 400 gig might be overkill today, but the argument in 2011 when we started, an MX240 was overkill. And by the time it's been taken out, I think it had some 100 gig links in it. We're doing the same thing again. So I think, am I there? I'm there. Right, so any questions, please let me know. Happy to share how we do things, okay? I mean, the team are here as well. Ask anything you like.
So thank you for that. You and I talked about you doing this back in March or May, whenever it was, Yes, so thank you for actually doing it. So 400 gig, it's a lot of expensive equipment and it's a lot of expensive labor. Nevertheless, you have the kind of community interest company that you are. Can you say whether you needed to get extra financing from your existing customers, or did you borrow money, or what's the financial model that supports doing this big extension?
Sure, I'm happy to answer that. And really, it was put to the community. And again, they want the best service going into the future, not just now. And so, yes, we did raise further funds from the community to go and do this project. And it was spelled out to them as we opened this up. And it was a long, long time ago, actually, we raised the money because lead times are horrendous. So, we had to wait a long time to get the gear. But yeah, it was pitched to the community. And they all supported it because it was the same sort of concept back when we started. They said, look, what do we want to do? Do we want to just make it work now? Or do we actually want to make the best choices and then keep it for a long, long time? And it was, I want to make the best choices and keep it a long, long time. So we've done the same again. So yes, raised further funds from the very community to afford to do this. Hello, Tom.
Hello, Tom.
How are you doing?
I love this. It's like a Spider-Man. Look at himself, isn't it? Right. You touched on traffic growth, actually.
Yes.
Right at the end there. And it's something I speak about a lot internally. Traffic growth is very interesting. We have a lot of traffic. You're getting a lot of traffic. How do you feel that the sort of industry developments around streaming TV are going to impact upon your idea of how traffic grows at the moment? Is it going to tick up? Are you ready for that? Are you worried about it?
It's a good question. And I think it's something that every operator needs to think about. Because the more and more services that come over the fixed line, the more and more usage you're going to get. The technologies improve. right? So then you're going to need more bandwidth for those technologies. And I would hope that when these new technologies are coming out, we're not trying to squeeze down to as little bandwidth as possible and just retain the quality of the service that you're getting. So yeah, TV services are going to be coming down your fixed line, right? Digital TV, all the rest of it. Yes, you can have all your dishes up. Just look at Sky Glass, all the rest of it. It's all going to be coming down.
Astra 2 and E is going to fall out the sky before the end of the decade. So.
Say again?
Astra 2, E and F will fall out the sky before the end of the decade. So yeah, there'll be a lot of Sky Glass.
Yeah, no, exactly. So yeah, in the projections, we're just seeing that actually, unless I'm wrong, the whole industry is focused to bringing everything down that fixed line now. And yeah.
Cool. And congratulations on your new voice service.
Oh yes, thank you. Thank you very much.
Hi, Ian from LonUp. Great talk.
Hello,
Thanks for that. Just two quick questions.
Yeah.
One, you said you put the fibre in the field 40 to 60 centimetres down. I wondered kind of what the failure rate of that is, like how often you've had cuts or other damage. And just another minor one, when you had the map of the country, there was a fibre going off towards Norfolk there, and then one at the top left there. Just curious what they were.
Sure. So the first one, get that question quite a lot. Yes, it is only 400 to 600 deep, so it isn't metres deep under the ground. So when organising the routing with the landowners, they know which fields they're going to plough, subsoil, use all of the time, and which fields they're not. And so what we find is a path. If you look at a network, it doesn't just go straight. It goes all over the place towards its destination.
You keep it to the edge.
You keep it to the edge, you keep it out of the way, and they never touch it. And the fact that you're consulting at that level with the landowners, you can get it right out of the way. Yes, they get cut, right? And, being honest, any fibre network will get cut. But the point is that you have enough resilience in the network that you can handle these chops. And then actually it's reasonably, I don't want to use the word easy because nothing is easy, but you can go out there and repair in a very quick time frame, right? You can get out. If something's happened, somebody's there. So then they usually ring us. And just without going on too long about this, within our way leave, it's a case of if a landowner by accident cuts it, we ask them to just call through and we won't charge them, right? So if they've done it by accident, some operators might want to charge for that, but we don't, which means we get the call, which means that we're out there straight away.
Yeah.
And because it's only 400 to 600, we found it, we can repair, reblow the fibre, splice into the chamber, done. So that's that one. And for the other nodes, they're actually spurs. So we have network in Norfolk, we have network in Cheshire.
Providing broadband?
Yes.
Okay, cool.
Yeah, exactly that. So they're just main spurs off the core network.
Cool, thank you.
All right.
Super interesting talk, so thank you very much. And just for being so open with all the questions. So question from me was, you showed the picture earlier and you had several volunteers in the bottom left who were doing the hard work. I know you've got kind of a core pay team, but you've also got a lot of community members as well.
Yes.
And I am well aware, I've personally endured the pleasures of working with civils engineers and having that subcontracted and that kind of thing.
Yep.
I'm wondering, do you use civil engineers, or do you have it pretty much all in-house between your paid people and volunteers, or are you ever using civil engineers?
Yeah, it's a good one, and we've actually got civil engineers who are cards in, and what that means is they almost feel part of the family, because the problem when you subcontract and then the subcontractors subcontract, you have real issues. You have real quality issues, you have real communication problems, and we just want to avoid that. So we've kind of gone the other way. So for all of the professionally built network, we use, it's all professionally built by the way, but we use civil engineers, right? So, qualified engineers to go out and we work in the streets as well now. We've held co-powers for a long, long time. But the fact is we don't have a subcontracting arrangement, we have them cards in. So it's labour that we're paying for, and actually it's all our plant, tools, equipment, machinery, etc. We also do have our own very much in-house civil engineering team, and again, because they have a seat at the table in the planning sessions and the development of the projects, they can raise all the problems that they think is going to come up with civil engineering, and you can solve it before you go down on the ground.
That is the correct way to do it. That's really good to hear.
Yeah. Thank you.
There was one last question from remote,
yes.
Which is your dark fibre network volcano-proof?
No. Yeah, no problem.
Hi, Tom.
Hello.
Very enlightening talk. Thank you very much indeed. The question I have is about, so obviously you're a community broadband, so I presume you had to have a telco license in place. Is that correct?
Yeah, so I mean, we went through the process of getting all of the relevant requirements, permissions, all the rest of it in the early days to become who we are. And we were very lucky that in the founding members, we had experienced people from Lancaster University, right? And I used to work for the team in Lancaster University as well. So going straight into it, we had everything set up ready to go. We only did get code powers in 2016 when we really needed them. When we first started, it was 100% agricultural build and using Section 50s with the council, etc. Right. But yes.
Well, I guess, and it leads to my other question is, so have you actually published the actual process of for other rural areas? Because I think you are not in the unique position across the UK. I think most of us knows that once you go outside these big cities, the coverage, broadband coverage is quite appalling in this country. But have you actually published the process as to if other communities in the area, across the UK, would like to get, almost like replicate what your success story that you've done? Yeah. What is the actual process? How do they actually acquire these licenses? And what do they need to do through the government process in order to do what you've done?
Yeah, no, absolutely. We've tried very hard at this, and there's been a few successes. So Fibre for Rural Nottinghamshire did their thing. Broadband for the Surrey Hills have done their thing. There are other examples as well. But yeah, it's just, you have to have the right people in the room, and it's almost a bit of magic to spark it to get going, and once you're going, you're off. So yeah, we've tried very hard, and we have had days where people can come and visit us and see what we do. We've been very open about how the whole thing works. So yeah. If anybody's interested, let me know.
Thank you.
Sorry, I'm taking a whole load of time here.
Yeah, I'm going to have to cut it off there because it's your fault for basically having a really interesting talk. So thank you very much, Tom.